Hello guys, greetings to everyone and welcome to my YouTube channel, Understanding Mathematics with Pride. Today, we are going to start with our first tutorial video. As you can see, we are going to answer these questions displayed in front of us. It says, solve for x in the following equations below. Question A, we have 2 to the power x is equal to 0.25. We have to answer this question. For us to answer this question, the first step will be for us to express the number 0.25 at the right hand side in index form with 2 at the base. We need to express this number in index form with 2 at the base so that we can easily equate the powers. Take the number 0.25. You know this number 0.25, writing it as a decimal fraction, this will simply give us it will simply give us 25 all over 100. Next step, we can simplify. 25 will go here 1, 25 divided by 25 will give us 1, 25 will go into 100 4 times. Next step, we know 4 can be written as 2 times 2. Next step, this will give us 1 all over. We know in indices, if you have 2 times 2 is the same as 2 to the power 2. We are multiplying 2 by itself, the number 2 by itself 2 times. Remember, if you have a times a, it's simply the same as a to the power 3. So this will give us 1 all over 2 to the power 2. Next, we have a law of indices which states that if you have 1 all over a to the power n, it is simply the same as a to the power negative n. This will give us, this is 1, 1, a is 2, n is 2. This will give us 2 to the power negative 2. Take note of that. Next, we are going to copy this our equation. It simply means we are going to copy this our equation, 2 to the power x equal to, where we have 0.25, we are going to replace 0.25 with 2 to the power negative 2. Next, you see the bases are the same. The left hand side is equal to the right hand side. Therefore, the powers must be the same. We are going to put down this symbol for implication. Simply means then implication sign. If 2 to the power x is equal to 2 to the power negative 2, then x must be equal to, the powers must be the same, x must be equal to negative 2. That's it. So if you replace x here with negative 2, you simplify, you obtain 0.25. Let's verify. If you replace x with negative 2, this will be the same as 1 all over, making use of this, 2 to the power 2, which is the same as 1 all over 2 times 2, which is 1/4. And 1/4 simply gives us 0.25. You can see the left hand side will be equal to the right hand side. You take note of that. And with indices, if you have a times a, let's say we are multiplying a by itself n times, this will simply be the same as a to the power n. You can see that's why we express 2 times 2 as 2 raised to the power 2. Next, we go now to the next question, question B, which says b log x is equal to 2. First, for us to answer this question, we know if we are given a number in index form, let's say we have a number a to the power b is equal to c, That means if you multiply the number a by itself b times, it gives you the number c, which is a positive number. Then for us to get b, if and only if, that means from this formula we can obtain what I'll write down. If and only if b, this b, we call b the power or the exponent or the logarithm. B is equal to the log of this number, this positive number c base e. That means this other arrow indicates that from this formula we have on at the right hand side, we can go back to the left hand side. Next, I'll write down this formula to look as such. I'll write it this way. Let's say we have log c base e is equal to b if and only if it's still the same thing. Remember, from this we can go back to this, so there's nothing new. And only if c is equal to e to the power b. So this is how we change from logarithmic form to index form, or from index form to logarithmic form. You can see here we have log x. The base has not been given. It's equal to 2. By convention, if we are given the log of a number, let's say we are given the log of a number n without the base being stated, the base is 10. So log n without any base is the same as log n base 10. Take note of this. Now, for us to answer this question, we have a log x is equal to 2. We need to change from logarithmic form to index form for us to get the value of x. So we are going to put down this our symbol, if and only if sign. If we compare them, let's compare this and this. We have log c base e. C is x, e is 10, b is 2. If and only if our c is x, if and only if x is equal to our e is 10, then our b is 2. Next, we need now to get the value of x. It is very easy now. X is simply 10 to the power 2. So therefore, x will simply be equal to 10 to the power 2 simply means 10 times 10. We multiply 10 by itself. This will give us 100. That's the value of x. It simply means if you replace x with 100 here, if you replace x with 100, you take the log of 100, it gives you 2. Let's do the verification here by the side. Let's replace x with 100. This is simply the same as, we know 100 in index form is simply the same as 10 to the power 2. It is the same as the log of 10 to the power 2. Next, if we apply the law of power, the law of power states that if you have a log e to the power n base b is the same as n, we are going to send out the power n log a base b. Then remember, we have another law which states that if you have the log of a base a is the same as, is equal to 1. So this will give us, if you apply the law of power here, this will simply be equal to 2 log 10. Remember, the base is 10 when no base is given. Log 10 base 10, according to this, is simply equal to 1. So this will give us 2 times 1, which is 2, you can see. So the exact value of x, the value for x is 100. Next, let's go to question C. Question C, we have the set equation root of 2x plus 1, the root of 2x plus 1 minus root x is equal to 1. The first step for us to answer this question, we need to start by sending negative root x to the right hand side. This will give us root of 2x plus 1 is equal to 1. When negative root x crosses the equality sign, it becomes positive. Then the next step, we need to square both sides so as to eliminate the square root sign here. Let's square both sides. Root 2x plus 1, we're going to square this, is equal to 1 plus root x squared. So when we square both sides, this and this will cancel. Remember, if you have a number, for example, let's say we have root a times root a, it is simply the same as the square root of a, all this squared. This and this will cancel. It gives us a. This and this will cancel. We'll be left with 2x plus 1 is equal to, in this case, it is not possible for you to say the square here, the 2 will cancel the square root sign. It's wrong. What of 1? You see, it becomes a problem. If we had, for example, the square root of 1 plus x as such, squared, then we are going to say this and this will cancel. But in such a case, it is not possible. So what we are simply going to do is, we know if we have a squared, it is the same as a times a. So in this case, we are going to take 1 plus root x, since we have all this squared, times 1 plus root x. Next, this will give us 2x plus 1 is equal to, we are going to expand. We're going to expand the brackets. 1 times 1 gives us 1, plus 1 times root x gives us root x, plus root x times 1 gives us root x. If you take any non-zero number, we know if you multiply any non-zero number by 1, the number remains the same. So it is the same thing with root x times 1. Next, we have plus root x times root x. This will give us root x squared as such. Next, this will give us 2x plus 1 is equal to 1 plus this and this are like terms. You can see that x has the square root sign here, x has the square root sign here. So it is the same as saying 1 apple plus 1 apple. It gives us 2 apples. So root x plus root x gives us 2 root x plus, now we have this, we know root x squared. Applying this will simply give us x. This and this will cancel. So plus x. Then the next step now, we are going to transfer all the terms at the right hand side to the left. This will give us 2x plus 1. When 1 crosses, it becomes negative 1. When 2 root x crosses, it becomes negative 2 root x. Next, when positive x crosses, it becomes negative x, equal to, since everything has been transferred this way, we are left with nothing, so it will be equal to 0. Next, Let's continue. This will give us 2x. You see that x here does not have the square root sign. 2x minus, bring the like terms together, minus x. X does not have the square root sign, so this and this are like terms. 1 minus 1 will give us 0. Take note, 1 minus 1 will go. This will give us 0. Then we will be left with minus 2 root x is equal to 0. Next, 2x minus x will give us x. It is, for example, you have, two apples. Then you have to subtract one apple from the two apples you have. You'll be left with an apple. 2x minus x will give us x minus 2 root x is equal to 0. Now we have an equation of this form. We need to find the value of x such that when we put that value of x here, we simplify, it gives us 0. You can see we have x here, while here we have the square root of x. Next thing we are going to do is we are going to start by saying let the square root of x to be equal to any letter of our choice which is different from x. In this case, we are going to say let x to be equal to the square root of x to be equal to t. Okay, we have the square root of x equal to t. Then if we square both sides, to eliminate the square root sign, because we need to know x in terms of t. So if you square both sides, root x squared is equal to t squared. This and this will go again. Then we'll be having x to be equal to t squared. So now we are going to replace it here. We know root x is t, x is t squared. So we are going to replace them here. That means we have the equation x minus 2 root x is equal to 0. Then we know x in terms of t is t squared minus 2. We know root x, this is a 2. Root x is simply t is equal to 0. It gives us a quadratic equation. Remember, a quadratic equation is simply an equation of the form ax squared plus bx plus c equal to 0 for a not equal to 0 and a, b, c are all real numbers. In this case, let's assume we have an equation, our quadratic equation of the form a t squared plus bt plus c equal to 0. A is not equal to 0. Like here, x, you must take note, x is a variable. Here, t, we have replaced x with t. T is a variable. If we compare this equation and this our equation here, we simply have a to be 1. T squared remains t squared. B is negative 2. We have c to be, since there's no c, no constant, because c is a constant term, it is independent of the variable. So that means c is simply equal to 0. And solving such a quadratic equation is very, very easy when the constant term is equal to 0. When c is equal to 0, we can simply solve this quadratic equation by the method of factorization. You can see here we have t squared. We know t squared is the same as t times t. Here we have minus 2t. We can factor out t. T is common. So if we factor out t, we know t times t, alright, t in bracket, we know t times t will give us t squared. The sign here is negative, minus. I'll bring down the minus, then I'll write down 2. I know t times negative 2 will give us negative 2t. Then I'll close the bracket. It's equal to 0. Next, we know t times t minus 2 is equal to 0. Then we have t is equal to 0. If you replace t with 0 here, 0 times anything will give us 0. Or t minus 2 is equal to 0 to get the value of t. Right? This will give us t to be equal to 0. I'll write it down. Or t is equal to, this is a linear equation, t minus 2 equal to 0. There's a certain value such that if you replace t with that value, you subtract 2 from it, your answer will be 0. T must be 2. In this case, t will simply be equal to 2. In most cases, we are going to say we are going to transfer negative 2 to the right hand side, which becomes positive 2. Next, we are not looking for t, we are looking for x. So we need to replace t with root x. Remember, we started by saying let root x be equal to 2, be t. So we are going to replace t now with root x. So if we take the first one, let's take a star for the first one. For t equal to 0, we are going to replace t with root x. T equal to 0. Then t, we know t is simply equal to the root of x. The root of x is equal to 0. Next, if we square both sides, root x, all this squared, is equal to 0 squared. This and this will cancel again. It gives us x to be equal to 0. Because if we take 0 times 0, it remains 0. So this is the first value of x. We go now to the second part. We'll write 2 star. Second solution, we have for t equal to 2, this part. So t equal to 2, then we know t is simply root x. Root x is equal to 2. Next step, we need to square both sides. Root x squared will be equal to 2 squared. This and this will cancel. We'll be left with x. X will simply be equal to 2 squared. We know 2 squared is the same as 2 times 2, which is 4. So it gives us x to be equal to 4. We are going now to conclude. We are going to conclude. Therefore, this is our conclusion. Therefore, x will simply be equal to, this is our rough working, x will simply be equal to 0. We are going to present the solutions in ascending order from the smallest to the biggest. X will be equal to 0 or x will be equal to 4. Underline these answers. You cannot say x will be equal to 0 and x equal to 4 because x cannot take two values at the same time. That's why we are making use of the word or. Now let's verify to see if our solution is correct. No, I'll just write down verification. Let's verify to see. We have the equation. Remember, we had the problem. The problem we had the equation. We had the root of 2x plus 1 minus root x is equal to 1. It simply means if you replace x with 0 here, or if you replace x with 4, after carrying out the necessary simplifications, you must obtain an answer of 1. So let's take the first one. Take the first hyphen for x equal to 0. Anywhere we see x in this equation, we are going to replace x with 0 here. Simply means if we replace x with 0 at the left hand side, after simplifying, we should obtain 1. So we have the square root of 2 times 0 plus 1 minus the square root of 0 as such. This will simply be equal to the square root of 2 times 0 gives us 0 plus 1 minus, we know the square root of 0 is 0. This will give us the square root of 0 plus 1 is 1. And in this case, we are simply going to take down the positive root. The square root of 1 is simply 1, which is true. Next, let's verify for the next part. For the second value for x equal to 4, anywhere we see x, we have to replace x with 4. This will give us 2 times 4 plus 1 minus the square root of 4. This will simply be equal to the square root of 2 times 4 gives 8 plus 1 minus the square root of 4. We know the square root of 4 is plus or minus 2. But in this case, we are working only with the positive root. So we are going to take positive root, which is 2. This will be equal to the square root of 9. 8 plus 1 gives us 9 minus 2, which is simply equal to the square root of 9. Since we are working only with the positive root, square root of 9 gives us 3 minus 2, and 3 minus 2 is equal to 1. You can see the verifications. So I'm very sure the solutions and the explanations are clear to everyone watching. Thank you very much for watching this video. If in case you have any doubts, then you can ask your questions in the comment section. Please do well to like the video and to share. Thank you very much.